In this video, we're going to continue our discussion of the reverse power rule, which we said before was if you want to take the antiderivative of some function x to the n power with respect to x dx, that's going to be equal to x to the n plus 1 over n plus 1 plus c. So just to remind ourselves, if we had x to the fifth power with respect to x, we want to take the antiderivative of that, we would get x to the 5 plus 1 over 5 plus 1 plus c, which is x to the 6 over 6 plus c. This power rule can be used for more situations, such as this. We have 3/5 x to the fifth power dx. There's a big difference between this x to the fifth and 3/5 x to the fifth, because we can only use the reverse power rule if it's specifically in this format, just x to the n. We only can use the reverse power rule for things that are just x to the n. So the first thing we'll need to do is take this integral and rewrite it. This 3/5 is just being multiplied by the x to the fifth, and we're allowed to just move the 3/5 out in front of the integral and just write it as x to the fifth dx. At the very end, after taking the antiderivative, we'll need to multiply that back through, but for now, we write it in this form, x to the fifth, because we know how to take the antiderivative of that. We have this 3/5 out in front times x to the 5 plus 1 over 5 plus 1 plus c, or 3/5 x to the 6 over 6 plus c, and then we'll just multiply through our 3/5. Okay, 3/5 times x to the 6 over 30, and we can simplify that. And then 3/5 times c. This is the interesting part. So 3/5 is a number, and c is any number. So we can write 3/5 c, but since we don't know what c is anyways, it's just some number, we don't really care that that number we don't know about is being multiplied times 3/5. So that part actually doesn't matter. 3/5 times a constant is just a constant. So we'll have x to the 6 over 10 plus that constant. Let's try another one. Let's try the antiderivative of 4x squared with respect to x. Once again, we want to take the antiderivative, but we only like things in the form x to the n power, so we'll take this 4 and move it outside the integral sign for now. We'll have 4 times x squared dx. Take the antiderivative of that using the reverse power rule. We have x to the third power over 3 plus c. And then we'll just multiply our 4 back through. So we have 4x cubed over 3 plus 4c. But once again, 4 times a constant, since we don't know what it is, it's just a constant. So we just write 4x cubed over 3 plus c is our final answer. Let's look at another example. Let's try 1/2 x to the negative 2 with respect to x. So we'll take the antiderivative of 1/2 x to the negative 2 with respect to x. First step is to move this 1/2 outside. We'll multiply that back in later. Then we'll take the antiderivative of this, keeping that 1/2 outside. That will get multiplied back in. So we have x to the negative 2 plus 1 over negative 2 plus 1 plus c plus some constant. So we get 1/2 x to the negative 1 over negative 1 plus c, which will get negative 1/2 x to the negative 1 plus c. And this can also be simplified a little bit more if we want, although we're probably fine here as well. We'll get negative 1 over 2x plus c. Let's look at one more example. And let's take a look at the antiderivative of 3x cubed plus 4x squared, and all of that with respect to x. So we only have one rule at this point, and it's the reverse power rule. And it looks like we can use that here as well. We're just going to need to rewrite this a little bit. So the first thing we're going to do is we're actually going to split this apart into two separate things. We can deal with 3x cubed and 4x squared separately. So our first step would be to rewrite this as 3x cubed with respect to x plus 4x squared with respect to x. It's almost as though this dx was being distributed to those two, and now we have two separate integrals we're going to look at. Now, once again, we still don't just have x to the n power. We have this pesky 3 sitting out front, and over here we have a 4 as well. So we'll need to rewrite this a little bit more before we take the antiderivative. So we'll write 3 times the integral of x cubed dx plus 4 times the integral of x squared dx. And now we have these things set up. It's time to finally integrate. All we did in these first two steps was rewrite the problem to make it easier on ourselves. Now we'll use the reverse power rule to have 3 times x to the 4 over 4 plus c plus 4 times x cubed over 3 plus c. And I didn't do the whole n plus 1 bit on the top and bottom. I think at this point you're probably pretty comfortable with that. I just skipped x to the 4th over 4 and x cubed over 3. And we're going to get 3/4 x to the 4th plus c. 3 times c is really just c since we don't know what it is anyways. Plus 4x cubed over 3 plus c. And then what's some constant we don't know plus another constant we don't know? Well, it's just a constant we don't know. So you're only ever going to have one c total, because c plus c in this case, since we don't know what it is, we still just call it c. So we have 3x to the 4th plus c plus 4x cubed over 3. And actually, I should probably reverse the order here. I should probably put 3 over 4th x to the 4th plus 4x cubed over 3 plus c is probably the most standard way you would see something like that.